Hello everyone, welcome to another problem session. So today we have a long problem, and so I decided to write it out. So this is a problem number 16 from JEE 2024 physics, this advanced physics part, paper 1. Okay, so I will walk you through what I wrote here. This is a lot of stuff here, and it was good to write it out. Okay, so this picture here tells the story of what the problem is. Okay, so you have a light ray that comes in and on a sphere, it's incident on a sphere. So this is incident ray, and then it's refracted. This is the normal. So if it comes on this side of the normal, it's going to go on the other side of the normal. And I've drawn it so that it's kind of symmetric, and then reflects off, and then it comes back out. So this angle over here is given as theta 0, and refraction angle is phi 0. And the question is about, they give it refractive index is n for this. So given refractive index, this angle, and the angle of deviation, which is incidence coming this way and exit is coming this way, this is the exit part. Then if you make the incidence line, then this angle is what is alpha. So that's also defined. Okay, so here's in this list, what I found is just answering P and Q was sufficient, and these guys are not necessary. Okay, so if I given refractive index and alpha, you're supposed to find what is the angle theta 0. So when you trace this, I found tracing was very important. When you trace this, you can notice quite a few things. If this angle is phi 0, then this angle is also phi 0, because this is AOB is isosceles triangle. These two sides are equal with radius. So these and these are also equal, and so angle of reflection is, this is the normal at B. So angle of reflection is also phi 0, and in this triangle, another isosceles triangle, then if this angle has to equal to that angle, there's also phi 0. If this phi 0, so it's incident phi 0, then of course it's going to come out at theta 0. This is just opposite of that. And the red lines here are the normals with respect to which the angles are defined. So the main work to be done is in down here. That's the main work. Okay. So if you look at the deviation, how much is the deviation alpha? Well, how do you get alpha? Well, you can say this I to this ray, say X ray, and this ray called Y ray. Okay, so these, how much is deviation from going I to X, and how much from X to Y, and from Y to E. So this is like I to X deviation, and this is X to Y deviation, and this is Y to E deviation. And then I just you can see this is simple geometry from this point, and at that point B, simple geometry, and point C, another simple geometry. And when you add up all the deviations, this is the formula you will get. This is the critical formula. So if this is the work that's required, that's what they're hoping you would do. And this you can use to actually answer questions. So if say P, if n equals 2 and alpha is 100 degrees, which I'm sometimes calling pi, sometimes calling 180 degrees, but that's fine. Then if you look at this, this will cancel that, and you'll get theta 0 will be 250. It's really 250. And then if I want to know what theta is in this question, in question P, so I can just over here apply the Snell's law, which will give me this Snell's law at A. And then because this half angle, you can just make theta 0 into another half angles of it, so that you can either cancel or bring it one side. Better bring one side, because theta 0 turns out to be actually 0. You can't cancel it. Cancel means you didn't divide by 0 over here. So this actually turns out to be actually 0. So if P is going to be that, P is that. So if you look at this P5, so this is, and this is. So A and B is the only thing I need to look at. So you can actually distinguish A and B from Q value alone. So you don't need R and S. So the Q value, you don't need new things to work. You just work over here. Alpha is pi again, but so this is again, but now the refractance is square root of 3 this case, and you work out the exactly same way, half angle, and when you this is the condition of theta 0. So you can see theta 0 has to be this angle has this means this part means theta 0 can be 0, but over here it means this theta 0 over 2 has to be equal to 30 degrees or pi over 6, and when you multiply by 2 you get 60 degrees or 0 and 0 because these two choices, and so this has to be 60 degrees. So Q equals to 2. So the answer is already A. And you can, after that you're done, and then you just, if you have some time, you can check it by given n equals this and alpha this. So this time so this is the same case as Q. This time I'm phi 0, but theta 0 is already found out. So this is actually just comes from the work we did over here already for Q. So the R is just a kind of, but R doesn't really distinguish, you're trying to distinguish A and B. Yeah, R distinguishes too, actually. So again, so these three are great, already distinguished, but S doesn't distinguish between these two choices. But you could check it if their value is correct, but I don't think you have the luxury during the test time. But anyhow, this is how you test S. You just use the condition given, Snell's law, that gives you phi 0, but then S is about finding alpha. So of course you had to have this thing done to get the alpha, and so that's the answer. So critically, this is the work that you have to do. That's it. So I will see you another video. Till then, bye.